Imagine you're working late on an important project. You finish up the last item or prepare to finalize. Oh no, a software glitch. You've just lost all of your data. It can be a frustrating experience, and if you're a software developer that's let an external escape occur, you've got a customer service nightmare to deal with. There are many reasons why projects fail, from schedules to costs, but let's focus in specifically on quality management. A good quality plan will not only find mistakes, but will find out the true culprit behind the mistake. It will reduce the chances of failures repeating themselves and find potential errors before they happen. A good project management plan will therefore find the true root cause of issues, identify the biggest opportunities for failure, and prioritize work to get the most value from your team. Taiichi Ohno, the founder of the 5 Why method, considers it the only way to get past the symptoms of a problem to discover the true root cause in order to solve the global issue. The method consists of asking the question why repeatedly until it cannot be answered again. Asking why 5 times is a good rule of thumb, but you can go more and find out more than one root cause. The idea is that once you've asked the question enough, the final answer is your root cause. Let's see an example. A user receives a program error while processing a request. Why? There's an error in the code. Why? Programmers didn't receive the proper training and an incorrect variable was passed on. Why was there no training? It wasn't in the project management plan. Why was the incorrect variable passed on? There wasn't adequate communication. So you can see there are 2 root causes to this error. The 5 Why analysis had to be continued down each path to get the root cause. Note that current experience avoids placing the root cause for something as human error. Every detail of a project should in theory be robust enough that the human variable is sufficiently removed. If you find yourself placing blame on an individual, then you most likely missed the root cause. Cause and effect diagrams go hand in hand with the 5 Why analysis. Various influences are reviewed and listed as contributing factors in the failure, shown at the end. Whereas the 5 Why analysis finds root causes, the cause and effect diagram identifies multitudes of contributing factors leading to the root cause. The most significant contributing factors are usually circled. Even more to the point, if one area shows lots of contributing factors, this could be an indication of a global issue within the organization. For example, the end result of an analysis may put the root cause as a technology error, but the cause and effect diagram could show that multiple issues associated with training may have enabled this failure to occur. Therefore, future problems could be mitigated by putting a fix in place for the contributors, in this case a training program. The 5 Why and cause and effect diagrams are the tools used most often for analyzing a failure after it has occurred. Now let's take a look at some more proactive tools for identifying issues before they become major internal or external escapes. Pareto charts are an excellent way to identify problems that contribute to a project being delayed or even failing. The project is created by adding up the number of failures or delays, called turnbacks, and plotting on a histogram. The issue that occurs the most is identified as the one with the most number of turnbacks. Most people know what a project's biggest issue is since it's probably the most talked about. Often though, many small errors can add up to more time wasted than a few major errors. The benefit then is that work can be prioritized based on the Pareto chart in support of the 80-20 rule, which seeks to reduce the effect of the top 20 issues, which will result in savings of 80% of the problems. Once a problem is identified for use, the issue should be run through the 5 Why and cause and effect diagram analysis for resolution. Obviously, common sense has to determine whether a significant, potentially project-failing issue is worked before a recurring smaller issue. Scatter diagrams are useful root cause analysis tools that are used for determining the relationships between variables within your project and the project's output. The chart is created by plotting various parameters against a failure mode. If there are groupings of data points close together or a trend, then an assumption is made that the variable has an influence on the output. In the example shown, data from various projects may show that runtime errors become more frequent as the number of manually entered inputs increases. Now let's look at some even more proactive tools used for preventing issues from happening in the first place. Flowcharts provide a graphical map of how logic and information flow. For large projects, establishing how information gets handled is critical to good communication and decision making. For instance, a project deliverable at a lower tier work breakdown structure level should be mated up at the next higher level. If the information flowchart did not clearly indicate this, then the deliverable may go up too far and bypass checks and balances. Laying out this groundwork provides a common way of doing business and is often referred to as standard work. As flowcharts are made for the various project details, potential flow errors can be identified for quick resolution. Although this tool is best used in the planning stages of a project, it could also be a good analysis tool to use in identifying the root cause of an issue. An organization that has lots of small projects may find a control chart beneficial. The tool plots data points through time on a continuously moving chart. Often, a rainbow chart is applied to the process to show how well the process is performing. Data points in the green are good, while results in the yellow require caution, and results in the red are not acceptable. The idea is that as you plot the various process data, a trend can be shown and problems in the future can be identified now. A process that is in control will have less than 7 data points in a row outside the green area. A data point that fails this so-called 7-run rule should be investigated further. As an example, let's say your vertical axis is the time it takes to accomplish a process. The data point in the red is a failure, but notice that the process was increasing, then steadied out, and increased again. This trend should be examined possibly with a scatter diagram to see what contributed to the failure. Also, this process has a 7-run rule violation, which, although not a true failure, requires closer examination. A good quality management program would require a 5-why analysis and cause and effect diagram to be created for these errors so that action items can be made to keep the mistakes from happening again. In summary, you have seen how quality management tools can be used to find the true causes of problems. You've also seen how quality management tools can be used to prevent problems from occurring. These important tools help organizations lower costs and remain competitive, and they are often required for your job. From fishbone diagrams to flowcharts, you can be a part of a successful project if you use even a few of these simple ideas. Thank you.